Okay, this subtopic is talking about analyzing a batch reactor using the method of access. So all the all the while we have been looking at cases where there's only one reactant involved. But however, in many cases, we always seen reaction where more than one reactant is present. So it's therefore difficult to isolate the effect from each of them, and then therefore difficult to find the order of the reaction for each of these species. So we will have to set up experiment that all the reactants are present in large excess except the one that we are looking at. So overall change in concentration is actually of the excess reactants are negligible. So we will look at some example to actually further clarify this paragraph over here. So for instance, we look at reactions of unknown kinetics. A plus B give you series of products. So negative RA is KCA to the power alpha, CB to the power of beta. So alpha is the order for A, beta is the order for B. So what we do is we need to do at least 2 experiments. So in the first experiment, CB reactant B is present in large excess, so that CB is effectively constant throughout the experiment. So what do we mean by that? So for instance, if let's say we A and B give you C, so we do I, C, F. So for instance that we want to say B is in great excess. This is for instance 0.5 millimole mole per liter, and B we can actually put 50 mole per liter. So you see B is in large excess, like at least 100 times more than A. So assuming that all the reaction has been all the A has been consumed, so 0.5 mole per liter plus 0.5 mole per liter, then your A at the end will be 0, but B will be 49.5 mole per liter and C will be 0.5 mole per liter. You look at B, the percentage change is in fact negligible because 49.5, which is very close to 50 mole per liter. So effectively we can actually consider that, say that B, the concentration of B did not change with time. So we have to use, then after that, the order of reaction of A can then be determined using either the integral method or differential method. So I need to mention that because from here, that minus RA is KCA alpha CB beta. So if B doesn't change, so B is also a constant. So we can write in this way that minus RA is K CB beta CA alpha. So this I just mentioned that CB is constant, is almost constant. So this is, we can group it and with the K term, so that this term is in fact constant, and therefore this will give you a new constant of K prime CA alpha. So this is just like a single reactant system that CA, that is only involving the change in concentration of CA, where K is now, this K prime is a new constant. Then like we say that we're going to use the integral differential method to determine. Then after that we will perform the second experiment. Now what we do is we change A. Just now B was excess, so now we have to make A in excess. So we would come back to this equation, CA alpha CB beta, and if we make CA in large excess such as CA does not change with time or negligible change in time, so this KCA alpha is now constant, and minus RA will be K prime prime CB beta. So we then determine B beta in a similar fashion.